Hello there, this is Randy. Today we're going to talk about what can we figure out about the behavior of a graph just by knowing the factors of its polynomial. Let's go. So the factor theorem states that given a polynomial, we'll call f of x, a is a zero of that function f of x if and only if x minus a is a factor of f of x. So this probably feels a little bit abstract, so let's do a couple examples to apply this theorem. So once again, we have the factor theorem here for reference, and we are given a function f of x equals x cubed times x plus 2 squared times x minus 1. And right here we can see the graph of that function. It looks like our graph has zeros at -2. There's a multiplicity of 2 at 0 with a multiplicity of 3 and another 0 at +1. Now, if what I mentioned about multiplicity felt strange to you, I would encourage you to watch our video on multiplicity of polynomial zeros. Now, just like in many other cases, this graph is not absolutely necessary in order to answer this question, but it helps us conceptualize what's happening. So right now, I would encourage you to read this question and pause the video and try to answer this question yourself before we do it together. Okay, now let's do it together. According to the factor theorem, here's that factor theorem, obviously, which of the following linear expressions corresponds to a root of f of x? Okay, before we answer this, let's try to take actual factors of this function and see how they relate to the factor theorem. So what I've written here are the factors of this function. So simply stated, what the factor theorem is saying is that any of these factors will give us a 0 or a root, right? Same thing, 0, root, or an x-intercept of the function. For simplicity, let's just write one factor for any factors that have multiplicity. And right now we're doing this the long way to really understand deeply what's happening, but toward the end, we'll talk about the shortcut to answering this kind of question. So first of all, let's try to write this factor, and this factor in the form x minus a. So if we write x in the form of x minus a, that would just be the same as saying x minus 0. And then x plus 2, in order to make this x minus something, we're just going to say x minus -2, right? Same thing, but now we have the form x minus a. So a is -2, a is 0, and x minus 1 is already in the form x minus a, so a is 1 in that case. So there it is. In terms of the factor theorem, a is 0 here, a is -2 here, and a is +1 here. And the theorem says that a is a 0 of the function. So let's see if each of these three numbers that we just found are actually zeros. Okay, well 0, there it is, x-intercept at 0. -2, there it is, x-intercept at -2. And +1, there it is, x-intercept at +1. Okay, so now that we understand the factor theorem on a practical level, let's try to answer this question as easily as possible. So when they say which of the following linear expressions corresponds to a root of f of x according to the factor theorem, they're just saying which of these is a factor of the original function, because we know that if one of these is a factor, we can find the 0 from that factor. Or in other words, we can find the root from that factor, or we can find the x-intercept from that factor. 0, root, x-intercept, same thing. So we just looked at all the factors of our function. So which of these options is a factor of the original function? X plus 3, no. X minus 2, also no. We have x plus 2, but we don't have x minus 2. X plus 4, also no. So that means that the answer should be x minus 1, and there it is. X minus 1 is in fact a factor of the function. So the answer to this question is D. So although you could have found this answer D really quickly by just asking the question, okay, which of these is a factor of the original function, now you understand the why, because we talked about the whole practical application of the factor theorem with the different factors and x minus a and everything. All that said, let's do one more example the fast way. So in this question, we have no graph, but we can still answer the question with the same logic that we used before. And here is the factor theorem again as reference. So they say consider the function to the right. Here's that function. According to the factor theorem, which of the following linear expressions corresponds to a 0 of f of x? Well, the question is, which of these options, based on what we talked about in the last example, is a factor of our function? It's that simple. So all of our factors of this function are x, x, x minus 5, and then x plus 2, x plus 2, x plus 2, and x plus 2. So given all of these factors, which answer over here is one of those factors? Obviously, x is the only option that is a factor, so option C. Sometimes it's easy to choose something like A because x plus 5 looks like x minus 5 and you might choose that on accident, but x plus 5 is not a factor of the function. X is the only linear expression of all these options that corresponds to a 0 of our original function. And that is everything for today. See you next time.